Welcome back, reinforcement learning. This session I explained building networks with Pytorch. Okay, Pytorch is one of the deep learning framework for practice the AI applications and machine learning applications and deep learning applications like a TensorFlow. It has a different, it's a very good platform, good environment to do the deep learning and reinforcement learning tasks. Okay, it is a compared with the TensorFlow, it has a different features. The first one is also support the tensors. Okay, the first one is it gives that it also support the tensors in PyTorch like a TensorFlow. That tensors in PyTorch is similar as the NumPy arrays. Okay, NumPy arrays we are defined with the NumPy dot array and list of elements. The same we are define the PyTorch tensors with import the torch and torch dot tensor and give the elements here. Here the 2 by 3 matrix, the 2 rows and 3 elements. Okay, they are displayed here. 1, 2, 3, 4, 5, 6. Okay, it gives the it supports the tensors. The tensors are indexed like a NumPy arrays. Okay, higher level tensors are called vectors, matrices, or more than matrices. We call the tensors. The next feature it differentiates the NumPy is automatic differentiation. Automatic differentiation. Another differentiation. Okay, we are need the differentiation operations in deep learning applications. The backward propagation requires a number of differentiation calculations. So these differentiation calculations are performed in TensorFlow automatically. Okay, just we mentioned the backward. It's calculate the gradients automatically. Okay, here see the torch dot tensor to 4 torch dot random elements y is equal to mx plus b, and the just losses dot backward. It's calculate the gradients automatically. Here the see the parameter requires underscore grade is equal to true. Okay, this indicates the gradients. It track the gradients throughout the computations graph, which are later used in the optimization process. Okay, we are must be enable the requires underscore grad is true. Okay, then it the track of the gradients is carry forward entire the computational graph. Next one is Pytorch. It is we are using Pytorch for neural networks building. We are construct the neural networks by using tensors using torch.nn module. We are using torch.nn module to build the neural networks using the sequential class. The sequential class is the stacked of the layers. Okay, see the example model is equal to torch.nn sequential. In this example, torch.nn linear layer and torch.nn ReLU activation function, torch.nn linear and torch.nn ReLU. Okay, here the 2 layers are there. Each layer is output is connected to the ReLU activation functions in both layers. The first layer is 10 inputs and 150 outputs. Second layer is 150 inputs and 4 outputs. Okay, in this example is also support the MSE loss. Okay, mean square error loss, and your optimization is Adam optimization. This is the we are using the torch for building the neural networks by using torch.nn module. Okay, loss functions are calculated by using the loss function. Loss is equal to loss function of the y predicted, y corrected. Okay, using the gradients, the loss dot backward gradient we are using for optimize the values of the weights. And training the network, after mention the loss function and optimization, we train the model. In the training the model, here that the number of epochs, number of loops, the steps are executed 100 times. Okay, in this loop, x is the input data and y is the the true output. Each step perform the forward pass through the model, compute the loss, calculate the gradients, and apply the optimization step in this training model. Okay, we also build the customized architectures in using Pytorch. Okay, customized architectures are we are built by using torch.nn module like as a previous one. Here import the torch.nn import module. Okay, import module and linear. Here model name is equal to mynet. Mynet model is built using this this customized layers and the activation functions. The layers are two layers are there. The first one is fully connected layer FC1 self.fc1 linear. Second one is a linear. The first one is 784 and 50 outputs, 50 inputs, 10 outputs, and corresponding activation functions are relu and relu. Okay, this is the customized architecture. Simple customized neural network. We can use this type of customized architectures for convolutional neural networks and recurrent neural networks type of models and advanced architecture, advanced models of the deep learning models. So the Pytorch is one of the framework to build to perform the task, to implement the task of the reinforcement and deep learning with efficient way by their features like it supports the tensors and it supports the automatic differentiation, and it is useful for it is very flexible for construct the different neural network modules. Thank you.